Once again, hearty welcome to the Math Revision Made Meticulous video series. Topic: Continuity and Differentiability. Differentiation by chain rule. Revision, as the name suggests, means looking back over previously learned information, ensuring that it is clear and fresh in the mind. 5 questions per video from selected topic is presented at this video series. The steps in answers are supported by the ideas used for getting the answer. Before you go for knowing the chain rule, let us try to recollect the rules on derivatives. If u and v are two real functions and u plus v the whole dash is u dash plus or minus v dash, that is you have to find the derivative of the first plus or minus derivative of the second, and u into v, this is called product rule. U v dash plus v into u dash, keep the first, differentiate the second, plus keep the second, differentiate the first, and this is called division rule. U by v whole dash is v u dash minus u into v dash by v square. Denominator square, denominator into differentiation of the numerator minus numerator into differentiation of the denominator. Now we will quickly recollect the formula once again, because formula are very important to do problems of differentiation. X power n, n into x power n minus 1, root x, 1 by 2 root x, e power x, a power x, a power x log a, log x, 1 upon x, sin x, cos x minus sin x, tan x, secant square x, cosecant x minus cosecant x cot x, secant x tan x, cot x minus cosecant square x, sin inverse x, 1 upon root 1 minus x square, cos inverse x minus 1 upon root 1 minus x square, tan inverse x 1 upon 1 plus x square. Derivative of composite function, and we are going to use chain rule. That is, if f be a real valued function which is a composite of two functions u and v, if suppose is f is v composition u, then t is equal to u of x we take, and if both the tt by tx and dv by dt exist, this is the chain rule. df upon dx is, first you differentiate with respect to v, then multiply with differentiation with respect to the t. Well, now we will take some examples so that the chain rule will be useful for you. Suppose if y is x power n, n into x power n minus 1, we are going to have y is equal to f, instead of x power n, we are going to have a function power n. For example, 2x plus 3 whole power 4, apply the formula 4 into 2x plus 3 whole power 4 minus 1 into differentiation of 2x plus 3. This is called chain rule. Now differentiation of 2x plus 3 is 2, therefore you got the answer. Similarly, suppose you have sin power 7x. It can be visualized as sin x whole power 7. Use the formula x power n, 7 into sin x whole power 6 into differentiation of sin x. You are seeing that we are extending the formula and differentiating the function in place of x once again. We got the final answer. Suppose you have a formula root x, it is 1 by 2 root x. Suppose you have any function inside the square root other than x. How to do? Very simple. 1 by 2 into that square root into d by dx of whatever inside the square root. You can remember like this. Therefore the answer will be minus 3x upon square root of 2 minus 3x square. Suppose you have square root of secant x. You know what is root x? 1 by 2 root x. Therefore 1 by 2 into square root of secant x. Again differentiate secant x once again by making use of chain rule. You got the answer now. You know the formula for e power x, it is simply e power x. Suppose you have e power any function other than x square plus 2, e power x square plus 2 into differentiation of x square plus 2, you got the answer. Suppose e power cos x, once again easy, e power cos x into differentiation of cos x, you got the answer. You have a power x into log a. Suppose you have any function in the power of a, for a power x cube plus 2x, it will be a into x cube plus 2x into log a into differentiation of x cube plus 2x, you know what is it. Similarly, a power tan x, it is a power tan x log a into differentiation of whatever in place of x, that is a function tan x to be differentiated again, it should be multiplied, for you got the answer. You have the formula for log x, it is 1 upon x. Whenever log of anything, it is log of x power 4 minus 2x is 1 upon x power 4 minus 2x into differentiation of x power 4 minus 2x. Therefore you got the answer. Similarly, log of tan inverse x, 1 upon tan inverse x into differentiation of tan inverse x. You got the answer. You have sin x is cos x, sin of any function, it is cos of that into differentiation of that. That's all you have to remember like this. Cos of that function to differentiation of that function. Suppose if it is sin of tan inverse, the same thing. Cos of tan inverse x into differentiation of tan inverse x. You got the answer. You have a formula for cos x as minus sin x. Therefore, minus sin of that into differentiation of whatever there in place of x, a function, whatever maybe it is. You have to differentiate it once again. Similarly, cos of secant x minus sin secant x into differentiation of secant x. You are writing the formula. Suppose if it is tan x is secant square. Suppose tan of something 3x square minus 7x. You have to differentiate it once again. Secant square of 3x square minus 7x into differentiation of that. You got the answer. Similarly, if it is tan of log x, secant square log x into differentiation of log x. Differentiation of log x is 1 by x. You got the answer. Suppose cosecant x is minus cosecant x cot x. For minus cosecant of root x is minus cosecant root x into cot root x into differentiation of root x. You got the answer. Suppose if it is cosecant of tan inverse x, you should be very careful. Minus cosecant of tan inverse, cot of tan inverse into differentiation of tan inverse. Secant x is secant x tan x. Secant of 1 by x square is secant 1 by x square, tan 1 by x square into differentiation of 1 by x square. 1 by x square differentiation is minus 2 by x cube. Secant of sin minus tan. Secant of sin minus tan, tan of sin x minus tan x into differentiation of sin x minus tan x. Differentiation of if y is equal to cot x and dy by dx is minus cosecant square x, if it is cot of 3x minus 2, it is minus cosecant square 3x minus 2 into differentiation of 3x minus 2. You got the answer. Suppose if it is cot of 3 cos x, then it will be minus cosecant square 3 cos x into differentiation of 3 cos x. I have shown you with a separate color of that function which is to be differentiated once again. Suppose if it is sin inverse x, differentiation is 1 upon root 1 minus x square. Suppose if it is sin inverse root x, what will happen? 1 by root of 1 minus root x whole square into differentiation of root x. It is 1 by 2 root x, therefore you got the answer. Now sin inverse of tan x will be 1 by square root of 1 minus tan square x into d by dx of tan x is secant square. Cos inverse x is minus 1 upon root 1 minus x square. Therefore, cos inverse of 3 minus 2x is minus 1 upon 1 minus 3 minus 2x the whole square, and differentiation of 3 minus 2x is minus 2. Suppose if it is cos inverse of tan, the same thing, minus 1 upon root 1 minus tan x the whole square, differentiation of tan x is secant square. You have tan inverse, it is 1 upon 1 plus x square. Tan inverse of x square is 1 upon 1 plus x square the whole square into differentiation of x square. Be careful. Extend the formula, differentiate whatever is there function in place of x in the original formula. That's all. Simple. You have to remember like this using the chain rule. Tan inverse sin x is 1 upon 1 plus sin x the whole square, and differentiation of sin x is cos x. Well, now let us now go for some problem where it will be function of function of function. Maybe chain rule to be applied 2 times. Log of sin root x, how to do it? First you apply log of something. Therefore it is 1 by sin root x into differentiation of sin root x. Once again apply what is differentiation of sin root x? It is cos root x into differentiation of root x. What is differentiation of root x? 1 by 2 root x. Till you are getting that x, you have to differentiate it again and again by simply going on multiplying. As you are going on doing it, it is called a chain rule. Okay, now this is having sin, tan inverse and root of x minus 1. What for sin first? It is cos of tan inverse into differentiation of tan inverse of root x minus 1. But the formula for tan inverse something, it is 1 upon 1 plus root x minus 1 the whole square in differentiation of root x minus 1. What the formula for square root of root x minus 1? It is 1 by 2 into square root of x minus 1 into differentiation of x minus 1. As such, differentiation of x minus 1 is 1, therefore you got the answer. Check out how this chain rule is being applied, function of function of function. But let us move on to some questions now from CBSE question paper and also from your NCERT textbook. Now this is 2 into square root of cot x square. Square root function, cot function, x square. Therefore, what is the first one we have to make use of it? We have to make use of square root of cot x square. Therefore, 1 by 2 into root cot x square into differentiation of cot x square. What is the differentiation of cot x? It is minus cosecant square. Therefore, it is minus cosecant square x square into differentiation of x square. You got the final answer. Now, at the last moment, you have to do simplifications, that all of you know. Let us go for another problem where it is cos of x cube into sine square of x power 5. Product rule is there and also chain rule is there. How to do this product? Keep the first function, differentiate the second, plus keep the second, differentiate the first. We are making use of product rule. Keep cos x cube, differentiate sine square x power 5, plus keep sine square x power 5, differentiation of cos x cube. How to differentiate sine square x power 5? It is sin x power 5 the whole square. Therefore, 2 sin x power 5 into differentiation of sin x power 5. What is the differentiation of cos x cube? It is minus sin x cube in differentiation of x cube. Come back to the next step. Differentiation of sin x power 5. Once again, cos x power 5 into differentiation of x power 5. What is the differentiation of x cube? It is 3x square. We are going to the final stage. Differentiation of x power 5 is 5x power 4. Simplify it and then give the final answer. Sometime in function of function rule they will ask you to prove something. Here it is given x plus root x square plus y square whole power n. First let us use the formula for x power n. It is n into x power n minus 1. Therefore n into x plus root x square plus a square whole power n minus 1 into differentiation of whatever inside that whole power n. Once again, let us go back to this. There are two terms are there. First term differentiation x is 1. Second term differentiation is square root of x you have to use. What is the differentiation of root x? 1 by 2 root x. Therefore, 1 by 2 into root x square plus a square into differentiation of x square plus a square. What is the differentiation of x square plus a square? It is 2x. We are simplifying it now. 2 and 2 will get cancelled. I will take LCM now. When I take the LCM, LCM is root x square plus a square. Numerator will be x plus root x square plus a square. Already there is x plus root x square plus a square whole power n minus 1 is outside. When I multiply, I will get n into x plus root a square x square plus a square whole power n by root x square plus a square. But the numerator is nothing but y. Therefore, ny by root of x square plus a square. Let us go to the next question. Once again, here one problem is given. You have to prove that dy by dx plus secant square of pi by 4 minus x is equal to 0. Whenever you are having trigonometric functions, remember that also inside square root you have to make use of properties of whatever the formula you have seen, maybe multiple angle formula or summation formula, whatever may be, to simplify it. Okay, let us try. Square root of 1 minus sin 2x by 1 plus sin 2x, but I am having a formula for 1 minus cos x and 1 plus cos x. For I will change it now. I will change sin into cos by making use of that complementary angle formula. Sin x is equal to cos of pi by 2 minus x. Therefore, I am making use of it. 1 minus cos of pi by 2 minus 2x and the denominator 1 plus cos of pi by 2 minus 2x. Once again, I am having a formula. 1 minus cos x is 2 sin square x by 2 and 1 plus cos x is 2 cos square x by 2. Therefore, let me divide it totally by 2. It will become 2 sin square pi by 2 minus 2x upon 2. Then 2 cos square pi by 2 minus 2x upon 2. 2 will get cancelled. What is pi by 2 minus 2x upon 2? It is pi by 4 minus x. And denominator also cos. Now we got square root of tan square pi by 4 minus x. Therefore, what is square root of tan square? It is simply tan. Therefore, y is equal to tan of pi by 4 minus x. Simply we have to differentiate it. What is tan of something? It is secant square of pi by 4 minus x into differentiation of pi by 4 minus x. Therefore, differentiation of pi by 4 is 0 and differentiation of x is 1. For you got minus secant square pi by 4 minus x. Bring it to everything to one side. Dy by dx plus secant square pi by 4 minus x is equal to 0. You have proved this result, but be careful in this result. You should not start that square root of something directly. It will be a very lengthy problem. You have to remove that square root by making use of properties of trigonometric functions. Well, let us go to the next question. F of x is mod of cos x minus sin x. You have to find f dash. For that, you should know the differentiation of mod x. For that, remember, if f of x is mod x, it is f dash of x is mod x upon x. Mod x upon x. X is not equal to 0. Therefore, when you use this formula, therefore mod of cos x minus sin x by x, that is cos x minus sin x, into differentiation of cos x minus sin. Differentiation of cos x minus sin is minus sin x minus cos x, and I have to apply pi by 6 everywhere. Your cos of pi by 6 minus sin of pi by 6 by cos of pi by 6 minus sin of pi by 6 multiplied by minus sin pi by 6 minus cos pi by 6. Now I am directly applying the value for cos pi by 6 and sin pi by 6. They are root 3 by 2 and 1 by 2. When I simplify it, I am getting as 1 by 2 multiplied by root 3 plus 1. Okay, well, success is dependent on the efforts. All the best. Thank you.